like, you just need to hold yourself accountable to get the work done as you're able to. So if we're not ready to be done with all of this work by next Tuesday, like the new work that I've assigned, I'll extend the due date, right? I'll make it longer. So this might turn into next Friday, but if we read right here, right, the new Khan Academy that I assigned has almost finished the unit. Like, we're almost done. So we're really close to the unit test. So if we get through content so that we're ready to keep this due date as next Tuesday, we might take the unit test next Thursday. But no, what I think you might be asking about also is about MAP. Guys, I, again, am not looking for if I need to update MAP. You just email me. I know that might be different than some other teachers, but like my email is my to-do list, like, and I will literally email myself something if I'm trying to remember to do stuff. So if you need MAP updated, all you got to do is email me and say, like, hey, would you please update MAP for December 18th or January 3rd, like whatever the due date was. Tell me what assignment you got done, like what it's called in MAP, and I will go update it for you. There are still some people knocking out November stuff, which is okay. Like, that happens. Sometimes things get, like, they slip through the cracks or whatever you want to say. Mason? It broke for a little while. Yeah, Con broke for a little while. So yeah, try it at extensions. It should work. And then, of course, guys, you remember your discovery day is Thursday. So tomorrow is still, like, technically a school work day. Like, you should be doing schoolwork at home, but tomorrow's still a school day. It's just your at-home school day. Next week, I will be collecting / checking your math notebook, binder, whatever you have. So for those of you that, like, have the fear in your eyes right now, even if what you have to turn in is a stack of papers, that's fine. That's not great, and that's probably going to end up being progressing, but I want to see how you've been taking notes. And if what you turn in is like, yeah, none of my notes from at home are really worth turning in, and here are my notes that I've been taking since we've been in school, like today and next week, that's okay, but that's probably going to be a progressing moving forward, just to, like, you got to show me that you're going to consistently take notes to get that to a mastery. So all of that to say, let's take really good notes today, since you know that I'm going to be collecting these notes next week. So if we want to head our notes, let's head it with solving proportions. And I may write these notes again with you guys. I've wrote them way too many times already, but hey, it doesn't matter. What's today's date? The 12th. So what we're going to get to is solving proportions, but we have a couple of things to talk about before we get to that. You guys need to help me remember, did we look at these tables already? Both of them? Yeah. So who wants to tell me what we said about the lemonade versus what is kind of eyebrow raising about the table on the right? Leah, since you sat in the back, you get called on first. Okay. Talk about the table on the left. Was it proportional? Yeah. Why? Because everything was multiplied by 3. Yeah, we could see times 3 both going down from, like, the x to the y, and we could see times 3 going across, right, from the little x to the big X. Nason, what was up with the table on the right? Was it? Why was it not proportional? Yeah, and 3 hours should be 60 if it was proportional to the 120. So if you need to write this reminder to check proportionality, and I forget exactly how we wrote it in your notes, but the 2 things that we were checking and guys, you could write this down really quickly. It's a pretty quick little notes thing. Unless you have it in your notes, and you might already have it, because we talked about this last week. We check the x to y, which we've talked about is our constant of proportionality. So here we said that was times 3 times 3 times 3. All of these are great. They're the same. And then the outside multiplication, and guys, I don't think we used this word last week, so I would like you to write down the word scaling this number that we multiply with to go from a small x to a big X. This is what we call the scaled, right? So this is scaled up or scaled down, right? So if we go from a little x to a bigger X, that is scaled up. And we want to ask, are they both scaled up the same? If x gets multiplied by 10, does y get multiplied by 10? So when we looked at Jace's table, the scaling that we could see is the hours triple on top and the pay does not. Right? The scaling of Jace's table does not work. Did we see the height and age table? Age and height? No. All right, perfect. So I want you to take a moment to look at this table. You can write it. Actually, yeah, let's go ahead and write it down real quick. So let's say that the age is our x and the height is our y. So if you want to write it down, I would put like an x next to age and a y next to height. Sorry, I gotta move my camera a little bit. And then after you copy the table and look at it for a moment, I want you to turn to somebody near you and discuss, do you guys think it's proportional? What do you think? All right, well, considering as soon as I asked the question, people said it out loud, like, well, and this room is just really what you call live. The sound carries. Yeah, people immediately said no, so it's kind of a waste of time if we sit here and say, okay, continue to talk about it. It's a no, it is not proportional, because this multiplication, or this constant of proportionality from 3 to 12, is a times 4. This is a times 5, and this is a times 6. So since the constant of proportionalities change, we can say it is not proportional. You can see what I've written out there. It is not proportional. Again, because the constant of proportionality changes, so then that fails. The next problem, we got two more is it proportional problems, and they are word problems, so you don't have to write anything down for these. I just want you to chat with a neighbor. Make sure you read this whole thing on the next slide, please. Oh, sorry, I forgot about this one. And I have forgotten about it like 3 times today. So, if we look at this table, and guys, I'm just going to go ahead and like tell you this because it's kind of like a little trick I want to teach you. Because I'm always trying to make your life easier. In this table, I'm going to zoom in a little bit. We have, that's a little far, but that's fine. We have y's that are all whole numbers, right? 2, 10, 50. Our x's are 5 over 6, 25 over 6, and 125 over 6. Notice that all of these x's divide by the same number, right? They all divide by 6. So we can temporarily ignore the 6. If we want to check, is this proportional, if we ignore the division by 6 and just look at the numerators, how does 5 go to 25? Well, I've already got it written up there. It's times 5, right? How does 25 go to 125? It's another times 5. So, if we ask ourselves, is this proportional? We check the bottom. Does the bottom scale in the same way? Times 5, and it does. So, that we can check these scaling multiplications times 5s and see that this is proportional, actually, because all of these check out. And actually, if you check the math to go from 5 to 2, or 25 to 10, or 125 to 50, this is all actually the same, because if we do the division, these divisions all come out to be the same. Hey, Samaj, are you with me? Are you doing what I'm doing, or are you like drawing stuff? Just make sure that you're just drawing what we're doing in the math. All right, so now we've got those word problems. So take a moment and read this. Turn to somebody close to you and discuss, do you think it is proportional? Is the price you'll pay, like the total price that you'll pay, is that proportional to the amount of tickets? Or, sorry, is this situation presented to us, is it proportional? Who wants to explain to us why? Harish, go ahead.
So you buy one ticket, so like one ticket costs $10.50, and you're not buying popcorn, so there's no additional taxes to it.
That's the trick. Say that again, the last part you just said. What aren't we doing? We are not buying the popcorn. So all we're buying is tickets. Let's say I'm taking us to the movies. I'm just going to take Reese because you just gave me the right answer. Or I start adding people in. How can I determine the price that we're going to pay? The price will be, well, how much is it per person? $10.50. Am I going to let anybody get popcorn? No, the popcorn's overpriced. So as long as nobody gets anything extra, then this is proportional. As long as nobody gets anything extra, it is proportional. As soon as somebody buys extra, like you get some candy or a soda or some popcorn, the price isn't proportional unless everybody does the exact same thing. So if all of us get a ticket and a popcorn, then it could come back to proportional again. If all of us get our own pizza, I don't know if movie theaters have pizzas or not, but like, then it could come back to proportional. But if only one of us get a pizza and one of us get a popcorn and one of us get a soda, like, that's not proportional. It's not the same. So check this out. Read it, chat with each other. What do you think? I think I'm going to switch masks because this one keeps falling down. Is this proportional? Anna's training. I have to take a moment to tell a dad joke, even though I'm not a dad. What does a percussionist name his twin daughters? Anna 1, Anna 2. Get it? And anyone in band should get that, because when you count, you say Anda 1, Anda 2. But instead of Anda, say Anna 1, Anna 2. It's alright, I never said that I was funny. Alright, Anna does sit-ups. Chat with your neighbor. What do you think? Is this proportional? She gets tired. She starts to slow down. She gets tired and starts to slow down. Brady, what do you think? Why no? Well, you can't just say it just doesn't seem like it. Can you tell me why it feels like it's not going to be proportional? Oh, guys, at what point was somebody going to tell me all my writing was still up here? So the thing I just was saying in the movie theater question was,
Every 2 seconds, but she's not going to keep up that pace forever.
she's not going to keep up that pace forever. Her pace, I love that you just said the word pace, her pace changes, right? It was 2 seconds per sit-up or push-up or sit-up, whatever she's doing. But then she slows down. So guys, when the situation changes, it's not proportional, right? That's pretty much our final, our last, we're going to move on to new stuff now. So remember, if we change a situation, if you decide to buy popcorn, or if Anna slows down how fast she's working out, it is not proportional. So now, if you need to, well, actually, you probably should anyways, draw a squiggly line across your notes because we're going to change gears a tiny bit. And this is where we're really going to start to solve proportions. So the first thing we want to say in this part of the notes is, well, what is a proportion? Proportion. Anyone remember what a proportion is? Preach?
So proportion is like when a number is like has a relationship or something like
Has to do with the relationship, yeah.
multiplication.
Yes. You're giving me a lot of aspects. I'm looking for 3 words, actually. Everything you said is right so far, though. Sorry, did I see a hand out of my peripheral, or am I making stuff up? Okay, I'm just crazy. It's okay. A proportion is a fraction equal to a fraction. You can write the whole word fraction if you want to, but I'm going to speed it up. So, guys, I really, 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 really love pizza. Yeah, you thought I was going to say my wife, didn't you? No, I'm joking. So I love my wife, but I love pizza too. So my wife and I decide to get pizza. Right? See what I did there? So my wife and I decide to get pizza, and I'm like, you know what? I'm really hungry tonight. I'm looking for something that's a circle, but all my tracing things are way over there. Yeah, they're all way over there. Draw a circle on your notes as best as you can. It's not going to go well. So I claim half the pizza. And we made it at home, so all I do is it's marriage, and this is my half, and this is your half. No, everything belongs to her. That's a joke. Come on, guys. I'm trying to make being at school more fun than being on Zoom. So we made this pizza at home. I cut it straight down the middle, and I'm like, this is my half. I claim this pizza in the name of Mr. Hudson. And my wife's like, dude, calm down. It's just pizza. But then she's like, no, Micah, you cannot just take this half of the pizza and eat it. First off, my dogs would probably attack me. Second off, that's weird to just take the whole half circle of pizza. So she's like, normal people cut pizzas into slices. No, my wife and I have a really funny relationship, and she honestly would treat me like this if I was trying to eat half a pizza just at one time. So she's like, Micah, you at least have to cut it into fourths. So I said, all right, well, when I cut it into fourths, I still get 2 of the fourths. And then I realized these slices are still kind of big, so I decided I might as well just go ahead and cut it into eighths, which is normal, especially if you're ordering pizza somewhere. So how many would I get then? 4 eighths. And just to be obnoxious, I decide that I'm going to stand in the kitchen for a while and actually cut the pizza into 24 slices just to show my wife I know how to cut slices. I know, but I'm just being obnoxious because she told me to cut it into slices. I would do something like this. I did not. This is not a real story, but I would do something like this. I would deliver her a tiny little sliver of pizza just to be funny. How many slices would I get if it's 24? 12. And these proportional relationships, right? I get 12 slices. These have the same relationships that we just talked about, those 2 criteria to check proportionality. The constant of proportionality here is times 2, right? If I check my x to my y, this is all times 2. So a proportional relationship still has the similar constant of proportionality. And then we also have that scaling. Because if I, double the amount of slices in total, I double the amount of slices I get. I don't actually double, the pizza I get, unless I take her half too. If I, on the outside, multiply by, what would this multiplication be from 2 to 24? Times 12. The top would also have to times 12, which it does. So proportions still do both of those things. They have that constant of proportionality and they have that scaling. So when we look at proportions, we can either compare top to bottom or left to right. Right? We can either compare top to bottom or left to right and ask ourselves, what is easiest? What is the easiest option? Now, the other thing that proportions do, just while we're talking about proportions, this is like a really important rule, so we're going to put a star here. Cross products are equal. Cross products are equal. What do I mean by that? Well, if we take let's say I'm going to take the 2/4 and the 12/24 just to have some fun numbers to work with. What we mean by that is really exactly what we said. We'll use some Syracuse colors. A friend who went to Syracuse. What is 4 times 12?
3.
What is 4 times 12? 48. Careful with trying to answer too fast, guys. And 2 times 24? Also 48. So we're not looking for the multiple that gets us there. We're literally saying, if I look at the diagonals of the proportion, like the top from the left side, the bottom from the right side, and multiply them together, they'll be equal to the other diagonal multiplication. Now, you don't need to remember this fancy name for it, but the fancy name for this is called the means extremes theorem. What we call it is cross multiplication. We just call it cross multiplication. Now, I need to find my poster about cross multiplication because it's lost in the move. But I will put that back up as soon as I can find it. I have and it'll be up in the classroom whenever we take a test or do anything else. But cough, cough, nudge, nudge, wink, wink, hint, hint. If we're potentially taking a unit test next week, and I'm also collecting your notes soon, do you think we might have an open notes test maybe? Man, I wonder if you might be allowed to use your notes next week, so we might want to make sure that we take really good notes today. All right, before we need to use that cross products or equal knowledge, though, we're going to start with some easier proportions right here. So please write down both of these, solving for K and solving for Q. I'm going to make K uppercase because my lowercase K's got made fun of earlier, so not really made fun of. Kids just kept saying, what is that? I'm like, it's a K. My lowercase k is just that, but when I write it really quickly sometimes, it just doesn't really look like a K because it's kind of too pointy. Yeah, it kind of more looks like an R that's too tall. But okay, so what we're talking about is look for, is there a nice, sorry, I did quotes on that, or an easier, right? We don't say easy. Is there an easier way to solve this as opposed to trying to do all this cross multiplication nonsense? Mason, do you see what could be easy here?
3 times 3 is 9. Then it can be 10 times 3, which is 30.
Yeah, everybody please draw on your paper. If this going from left to right is times 3, then this going from left to right, So essentially, because somebody said this morning, and this is the rule, I just don't like having you guys just memorize rules. What happens on the top happens on the bottom. What happens on the left happens on the right. And you can turn those around. So now if you're trying to like make math difficult, you might do this. If you figure out what the multiplication is out here, that's the same multiplication that happens out here. But is it easier to go from 3 to 9 or from 3 to 10? 3 to 9, right? That's just times 3. This is the nicer way to get to k. So we just say, well, on the top, it will also do times 3. On the outside, it would actually be times 3 and a third. 3 and an extra third. So if we times 3 across the top, what does k become? What is k? 30. Any questions on how we get that k is 30? By the way, guys, I'm not making your seating chart till next week. So if you realize that, like, oh, maybe you can't see as well as you thought from where you're sitting or whatever, please let me know, like, if you need a seat up front or something like that. Try to solve Q on your own. I'll go ahead and give myself space. Is it easier to compare top to bottom, bottom to top, that sort of thing, or left to right? Which is the easier way to look at? Left to right, right? Because top to bottom, 3 to 5, or 5 to 3, like it's not terrible, but it's not very nice. This is much nicer, right? What is this? 2, right? To go left to right. Sorry guys, when we're in class, if I don't call on people, you can just talk. Like we're just having a conversation, right? Sorry that education has broken you into thinking you're not allowed to just speak. I'm really not one of those teachers who will ever say, "Why didn't you raise your hand?" Like that's just talk. If you got something to say, say it. So if this is times 2 across the bottom, it has to be times 2 across the top, meaning Q is yeah, Andy's James Bond's gadget guy, who actually knows what I'm talking about. Oh my gosh. Leah's the only person with a half hand. Q is like the really smart dude who makes all of 007's gadgets. Like the car and the... I'm just going to stop. Yeah. My Q? See? Thank you. I get made fun of for everything I do. No, so it's really like this because of a cursive Q. Oh, snap. Cursive Qs are like something like, I don't know. Cursive Qs are really weird. But that's why some of my letters look weird when I make them, is because I had to write in cursive. Right? Yeah, you guys never had to write in cursive. So my handwriting is a little weird now that I print everything, but used to write in cursive. All right, try this on your own. You got so good on those last ones. And then turn to a neighbor and lament to each other about why this one's not as easy as the ones that we just did, and what might you try to make this work. All right, so now that we're back in class and I have a list of you guys here, I'm really just like randomly calling on people that I haven't really like heard from today or like, recently or whatnot. So please chat with each other. So if I call on you, you're more likely to have talked to somebody about this, but remember, you can always pass. So take a moment, chat with the person near you. What do you see here? What do you recognize as happening? What might be an issue? What might we try? Go for it. Yeah, all right. None of you guys want to talk, do you? You're breaking my heart. Delaney, what do you notice is happening here? We have to find a denominator instead of a numerator, right? This was numerator we had to find. This was numerator we had to find. All right, so if we need to find the denominator, let's look at what happens in the numerator and then try to copy. What happens in the numerator? We multiplied by 3. So in the denominator, we just multiply by 3, right? So we take z and we just... Oh, wait. How is multiplying by 3 going left to right going to help us when I need to find the number on the left? So, Leah, what could I try instead? I need to go right to left instead of left to right. Well, if I'm going the opposite direction as when I multiply, what should I do going this way since it's the opposite direction? Divide! Instead of multiplying, since we're going the opposite direction, we use the inverse operation and we divide. So z is actually going to be the 5 divided by 3, which comes out to be 1.6 repeating. But again, this is when decimals are kind of gross. That 1.6 repeating is actually not as precise as 5/3. So you could leave it as 5/3 if you want. You could put 1.6 repeating. Khan may not let it slide though. But, Harish? Yeah, so if we look this way at what's happening, I'm going to write in purple. If we look this way for what multiplication still works, it is times 1/3. And 5 times 1/3 is 5/3, right? So we will get the same answer. All right, sweet. So what happens, though, if, like, this 12 is not a nice number? What if it's like a 13? Have no fear. I have a method that always works. So go ahead and copy down this top proportion, but don't solve it yet. Copy down that top proportion, but do not solve it yet. The method that a lot of like your siblings or parents or like anytime you go show like someone that just learned tricks, I shouldn't really say it like that. I can tell when people just memorize stuff, right? Versus like think about how to solve things. So the first thing I want you guys doing when you see a math problem is thinking, right? Think about what makes sense here. But when we think about going from 7 to 8, that multiplication is kind of tough. If I think about going from 8 to 7, that gets smaller, and that multiplication is kind of tough. 8 to 12, that doesn't seem too bad. We could probably solve that and copy it. But the other thing we can do is apply a technique that I don't want you to always use. Because I want you to think first. You don't need to always use this. On these situations up here, doing cross multiplication is not necessary. But on a situation like this where it's kind of messy, we are going to cross multiply. So go ahead and write this down, please. And I'm writing it beside it so I can like label steps and color code it. So cross multiplication always works. And that's why we can use it, because it always works. So to cross multiply, the first thing we do is equal out the cross products. And by equal cross products, like I'm just going to write these three words, equal cross products. What I mean by that is it's what we are doing. We are making the cross products equal. What are the cross products again? It's the diagonal multiplications. It doesn't matter which one you write first. My preference is put the variable one on the left side. So I'm going to do 8 times k on the left side, but it doesn't actually matter. And then I'm going to do 7 times 12 on the right side. So that was our step 1. We made equal the cross products were the diagonal product, meaning multiply, right? So, okay, we got to do this. We get 8k equals, what's 7 times 12? Well, we can do 7 times 10 and then 7 times 2. 70 plus 14, so 84. Then step 2 of this process, I hope I haven't lost you. I see some people not holding pencils, which makes me real concerned because I'm checking notes next week. Step 2 is to isolate. What does isolate mean again? Get alone, right? Isolate the variable. And we do that by using inverse operations. So what we see happening to the variable is multiplication. Guys, what will undo multiplication? What's the opposite? Division. So we divide. Got to do it on both sides, but we divide by the number we want to get rid of. Because that makes a giant 1. Of course, we all love the giant 1. So we just get k. It's isolated now. K is, well, 80 divided by 8 would be 10. 4 divided by 8 is another half. So it'd be 10 and 4/8, or we can say 10 and a half. Or if you really like decimals, you can say 10.5. Try to solve for n on your own. Like that one at the bottom. Do the cross multiplication. Do the division. Try to get that variable by itself. Guys, if you don't have a calculator with you, please try to bring one next week. My box of calculators disappeared. It's somewhere in the gym. At least I hope. But I have very few calculators in my room right now, like maybe 10. So please bring your calculators to school next week. This one is also not nice, right? If I look about getting from 8 to 5 or 5 to 8, or from 8 to 11 or 11 to 8, like none of that seems easy. So we got to do cross products. Ray, you got the answer? Can you tell me what to do? What would I write beneath here now? What do I get from what I highlighted in blue? Yeah, so I'm going to put the 8 first just because it's a little bit nicer that way. So 8 times n equal to what? Yeah, the other diagonal. So 8n is actually 55. Caroline, what do I do now to get rid of this 8 that's attached to the n? How do we undo multiplication? Yeah, we divide. So we divide by 8. divide by 8. And n, guys, I like fractions. Improper fractions are allowed as well. You could leave it like that. 55 over 8. Sorry, my little screen's in the way. Or, I think this is 6.875. Somebody do this in your calculator if you can, please. Mine is dead. 55 divided by 8. Please do not be impressed by that. I did this problem already. I can't do that math in my head. So if you think I just figured that out in my head, no, I did not. Well, way to be a show-off. No, I'm just joking. Good work. I applaud you for doing that. But at this point, we're using a lot of calculator work. So don't be afraid to grab that calculator. Let's try another one. Try both of these. Here, I'll leave my notes up for the last problem. So if you need to see my process or like the directions or whatever. If you don't have a calculator, the furthest you can really get is writing that improper fraction, but that's okay. If you don't have a calculator, the furthest you can get is probably writing that improper fraction. What you looking at? My setup? I like it. I like these rooms. They're wall spaced. We're trying to cross multiply, Mr. Estes. It is tough. All right, can I flip from this page and go ahead and write down the new problem? Sorry, did somebody say wait?
That's a good question right there.
Well, the license plate one? Yeah, I'm going to start to try to do things like that at least once a month, but I would hope for once a week. But, like, just the random math questions that make you, like, scratch your head. I'm like, how could we do that?
I read
Now.
something about telephone numbers, and they thought that they could never run out because they were just seven, because they, based on just the number of properties that can be.
Yeah.
But, cell phones blew it up.
Right, exactly. The real question that I should ask with that is if every license plate could only have 6, because that's easier, actually. But then the harder question is if you could have 1 digit or 2 digits or 3 digits. That's the more, because it makes it a much bigger set.
Yep.
All right, sorry, Mr. Estes and I will stop nerding out. Anyone want to walk me through this process? Any volunteers to be so bold? Yeah, Harish, go ahead. Now, this might be the last time I get to call on you today, though. Because I got to make sure I see other people. And we're almost out of time, I think.
So first we have to cross multiply 4/3 by 11k.
By the way, sorry to interrupt you, Harish. If you don't have a highlighter, just circle. So if you did not circle or highlight these, please go back and at least circle them. And this is also why sometimes people call this the butterfly method. It sort of looks like a butterfly. If you add a little body and some antenna here, it looks like a butterfly. Oh, it's cute. So yeah, Harish is right. We do 4 times k, 3 times 11. What's 3 times 11? 33. What do we do now?
Now we divide by 4 on both sides.
Very good. What do you get?
33 over 4.
Yeah. if we leave it as a fraction. Did you also find the decimal? What is that? Sorry, what is it? 8.25. Any questions for Harish? I didn't solve that, he did. Do I have a volunteer for the next one? All right, Sonny, I'm going to come to you. Can you walk me through how to do this?
So first you have 10 times, so you have the cross multiplication for 10 times 2 is 3 times 9.
So the 10 times q just stays 10 times q. What is 3 times 9?
30.
Ooh, close. Careful. Yeah, so we get 10 times, oh, sorry. This is q, at least I think it's q. Yeah, it can be q or y or whatever you want it to be. Yeah, 10 times the variable. 9 times 3 is 27. What do we do now? Absolutely. And we get q is equal to. Remember that when we divide by 10, we just move the decimal place. So we get q equal to 2.7. All right, the last thing I need to show you really quickly, and then there's obviously people waiting at the door. When we go to set up a proportion, you can do it 4 different ways. So the tricky thing about it is, let's say that you were given 4 glue sticks cost $7.76. How much does 13 glue sticks cost? There are 4 different ways to set it up. You can do cost over glue sticks and then equal to cost over glue sticks. You can flip that upside down and do glue sticks over cost equal to glue sticks over cost. You can actually also, please give your attention up there really quickly, sir. You can also do glue sticks compared to glue sticks is equal to cost compared to cost. So guys, you will be asked questions in Khan Academy that utilize all 4 different types of setting up a proportion. This is in the very end of a couple of my class videos, but this is also where we're going to pick up next week. So please realize there are 4 different correct ways to build a proportion. Once you get your desk wiped off and everything packed up, you can head on out. Remember, I'm collecting notes next week, so please keep track of those. Do not lose them. Do not feed them to your dog. Thank you very much. Have a wonderful day, guys.